In this lecture, I'm going to discuss some properties of Euler's functions. We'll go to the theorem. For any n greater than or equal to 1, so where n is a positive integer, the sum of positive integers, so less than n, and these integers relatively prime to n is 1 by 2 into n into pi of n. So that is to prove that sum of k is equal to 1 by 2 into n pi of n, where k is the integers from 1 less than k less than n, such that you have to choose k values such that from 1 to n, that is GCD of k comma n is equal to 1. So you have to prove that sum of k is equal to 1 by 2 into n into pi of n. It means sum of k nothing but the sum of positive integers less than n, so that they are relatively prime with n. So we'll move to the proof of the theorem. Let a1, a2 and so on, a pi of n be positive integers, so these are must be less than n, and they are relatively prime to n. That is GCD of a1 comma n is equal to 1, GCD of a2 comma n is equal to 1, and so on. So GCD of a pi of n comma n is equal to 1. So these integers are relatively co-prime to n, and these integers must be less than n. Since GCD of ai comma n is equal to 1, where I is equal to 1, 2 up to pi of n, if and only if GCD of n minus ai comma n also 1, where I is equal to 1 to pi of n. So you can observe from the example. Let us take let n is equal to 8. There are integers less than 8 relatively prime with 8. So these integers can be written as 1, then 3, 5 and 7. So these integers less than 8, and they are relatively prime with 8. That is, so GCD of 1 comma 8 is equal to 1, GCD of 3 comma 8 is equal to 1, GCD of 5 comma 8 is equal to 1, GCD of 7 comma 8 is equal to 1. You can observe that. If we take where n is equal to 8 and ai is equal to that a1, a2, a3 and a4 we take. Suppose if n minus a1, 8 minus 1, so 7. So 7 is relative prime with 8, that is equal to 1, which I written here. Suppose if we take n minus a2, where a2 is equal to 3 here, so 8 minus 3, that is equal to 5. So GCD of 5 comma 8 is equal to 1. So similarly n minus a3, so where a3 is equal to taken as 5, so 8 minus 5 is 3, so GCD of 3 comma 8 is equal to again 1. So n minus a4, where a4 is equal to 7, so that is the 8 minus 8, 8 minus 7, sorry, 8 minus 7 is 1, so GCD of 1 comma 8 is equal to 1. Yes, so therefore it is written since GCD of ai comma n is equal to 1, so if and only if GCD of n minus ai comma n is also 1. So with example verified this, then we can write then the numbers numbers n minus a1, n minus a2, and so on, n minus a pi of n are equal to the numbers a1, a2, and so on, a pi of n in some order. You can observe that here. So in this example you can observe that n minus a1 is 7, so n minus a1 is equal to, that is a4, n minus a2 is 5, so 5 is equal to a3, a3 is equal to 5, n minus a3 is 3, so 3 is equal to a2, where a2 is equal to 3, n minus a4 is 1, so 1 is equal to that 1 here, a1. So therefore you can write the numbers n minus a1, n minus a2, and so on, n minus a pi of n are equal to a1, a2, and so on, a pi of n in some order. Therefore sum of the positive integers a1 to a pi of n must be equal to a1 plus a2 and so on plus a pi of n must be equal to n minus a1 from here plus n minus a2 and so on plus n minus a pi of n. So you can observe that sum of these integer must be equal to sum of the, so n minus a1, n minus a2, and so on n minus a pi of n, because they are equal in some order with the positive integers a1, a2, and so on a pi of n. So this is equal to, just group the n, there are pi n terms here, n plus and so on n, there are pi n times here, then minus of a1 plus a2 and so on plus a pi of n. So this is equal to n, there are pi n times, so n into pi of n I can write minus a1, minus of a1 plus a2 and so on plus a pi of n. So this implies in the LHS we have a1 plus a2 and so on a pi of n, and RHS minus of this, just take it left hand side, therefore you can write 2 times of a1 plus a2 plus and so on a pi of n is equal to n into pi of n. So this is equal to a1, this implies a1 plus a2 and so on a pi of n is equal to 1 by 2 into n into pi of n. So this is the result. Therefore, you can write, or hence the sum of the positive integers less than n that are relatively prime to n is 1 by 2 into n into pi of n. So that is I can write sum of k is equal to 1 by 2 into n pi of n, where k lies between 1 less than k less than n and GCD of k comma n is equal to 1. So now we will verify the result by taking n is equal to, for example, n is equal to 8. So there are integers less than 8, they are relatively prime with 8. So these integers are 1, 3, 5 and 7 less than 8. So these integers are relatively prime to 8. Since you can observe that, so GCD of 1 comma 8 is equal to 1. So GCD of 3 comma 8 is equal to 1. So GCD of 5 comma 8 is equal to 1. So GCD of 7 comma 8 is equal to 1. So therefore pi of 8 that is equal to 4. There are 4 integers less than 8. So the 4 integers are relatively prime with 8. And the sum of the positive integers less than 8 that relatively prime to 8. So that is equal to there are integers 1, 3, 5, 7 less than 8 and this integer less than 8 and relatively prime with 8. So let us take sum of these integers 1 plus 3 plus 5 plus 7, so is equal to 60. And 1 by 2 into n into pi of n, so that is equal to 1 by 2 into, where n is 8, into pi of n we calculated, that is 460. So result is verified. Therefore the sum of positive integers are less than 8 and that are co-primes relatively prime to 8 is equal to 60. Let us consider another number. Let n is equal to 12. So there are integers 1, 5, 7 and 11 less than 12. So these integers are relatively prime to integer 12. So therefore pi of 12 is equal to 4. There are 4 integers less than 12 and these integers are relatively prime with 12. So now we have to calculate the sum of the positive integers 1, 5, 7 and 11. The sum of the positive integers less than 12 and that are relatively prime to 12 is equal to 1 plus 5 plus 7 plus 11, 1 plus 5 plus 7 plus 11, so that is equal to 24. And let us calculate, so 1 by 2 into n pi of n, so 1 by 2 into where n is 12 into pi of n is 4, so 2 to that is 24, therefore result is verified. So let us take another example. Let n is equal to, if I take 30, so there are integers 1, 7, 11, 13, 17, 19, 23 and 29 less than 30, so that are relatively prime with integer 30. So therefore pi of 30 is equal to, there are 8 numbers less than 30 and these integers are relatively prime with 30. So now the sum of positive integers less than 30 and that are relatively prime to 30 is equal to, there are these integers 1, 7, 11, 13, 11, 19 and 23 and 29 are the relatively prime with 30, so their sum is 1 plus 7 plus 11 plus 13 plus this is 17 plus 17 plus 19 plus 23 plus 29, so their sum is 120. And let us calculate 1 by 2 into n into pi of n, so where 1 by 2 where n is so 30 into pi of n is 8, so this is equal to 4 the 3 4 the 12 120, so result is verified.